Hi everyone. Today we're going to study sample problems for this topic, Fourier expansion of odd and even function. Example 1. Expand f of x equals x as a Fourier series in the interval from negative pi to positive pi. The given function satisfies the condition f of negative x equals negative of f of x, and hence f of x equals x is an odd function. So for odd function, the Fourier expansion formula is simplified into like this. Then the b sub n formula is equal to 2 over pi times definite integral from 0 to pi of the function f of x times sine nx dx. Substituting based on our given problem f of x, we have now this b sub n equals 2 over pi times definite integral from 0 to pi. F of x is now changed into x times sine nx dx. Remember, when we solve for b sub n, we are using the Bernoulli's formula, and this is the formula for that. Then we will collect the u and dv respectively. The u equals the function x, while the dv is the sine nx dx. For the function u, we will differentiate continuously till it reaches 0. So u prime is equal to 1, u double prime equals 0, then we stopped. For the dv, we're going to integrate up to this level where the derivative equals 0. So integral of dv is v equals integral of sine nx dx is negative 1 over n times cosine nx. The integral of v is v sub 1, and this is equal to negative 1 over n squared times sine nx. Now let us substitute the corresponding values to our Bernoulli's formula. We can get the b sub n equals 2 over pi. We have this pair of factors. This is u times v. Minus, we have another pair of factors. This is u prime times v sub 1. Then we will evaluate this with respect to the limits from 0 to pi. We have now these two groups. Look at the second group. Because of the 0, this will be cancelled out. Then we will apply the standard results where sine nx equals 0 and cosine nx equals the negative 1 that is raised to n. For this second group here, this will be cancelled out because of the sine n pi. For the first group, the cosine nx, we will change later into this value, negative 1, that is raised to n. Looking at the remaining expression here, we can cancel this pi in the denominator and the pi in the numerator. Simplifying further, we have now this negative of 2 times the negative 1 that is raised to n all over n. This negative sign here we can write as negative 1. Then this negative 1 we will combine with this negative 1 that is raised to n by simply adding the powers. So final answer, 2 times the quantity negative 1 that is raised to n plus 1, then all over n. This is the value of our b sub n. We will now simply substitute the value b sub n to the Fourier formula. So it becomes like this. This is the final answer. Example 2. Expand f of x equals x squared as a Fourier series in the interval from negative pi to positive pi. The given function satisfies the condition f of negative x equals f of x. That means this function f of x equals x squared is an even function. And for even function, the Fourier expansion is simplified into this formula. F of x equals a sub 0 over 2 plus the summation from n equals 1 up to n equals infinity of this function a sub n times cosine nx. Let us solve now for this a sub 0 and a sub n. The formulas are here respectively. Let's begin solving a sub 0. The formula is 2 over pi times the definite integral from 0 to pi, f of x dx. With our given f of x equals x squared, we will substitute the value for the f of x. We have now here as x squared. Let us now integrate. The integral of x squared is x cubed over 3. Then we evaluate this with the limits from 0 to pi. We have now the two groups, pi cubed over 3 minus 0 cubed over 3. We can cancel this pi in the denominator with a pi cubed in the numerator. So final answer, we have now this 2 pi squared over 3. This is our a sub 0. Let us solve for a sub n. Let us now substitute the value of f of x as x squared. Remember that when we solve for a sub n, we always use the Bernoulli's formula. It means we need to collect the values of u and dv respectively. It's usual that the u is equal to the x squared, and the dv is the cosine nx dx. We take the derivative of the function u until it reaches 0. So u prime equals 2x, u double prime equals 2, u triple prime equals 0, then we stop. For the dv, we will integrate continuously. The integral of dv is v equals integral of cosine nx dx is 1 over n times sine nx. The integral of v is v sub 1, and this is equal to minus 1 over n squared times cosine nx. The integral of v sub 1 is v sub 2 equals negative 1 over n cubed times sine nx. Then we substitute the value of this into our Bernoulli's formula. We have now the 2 over pi times this pair of factors. This is our u times v minus the second pair of factors. This is u prime times v sub 1 plus the third pair of factors. This is u double prime times v sub 2. We will evaluate this with respect to the limits from 0 to pi. We have now the two big groups. Look at the second group. Because of the zeros, all the terms of the second group will be cancelled. And for the first group here, we're going to apply our standard results. Meaning, for sine nx, this is equal to 0. The first and the third terms are cancelled. For the second term here, the cosine n pi can be changed into negative 1 that is raised to power n. It becomes like this. Simplifying further, we can cancel the pi in the denominator with this pi in here, and the final answer will be 4 times the quantity negative 1 raised to power n over n squared. This is the value of our a sub n. Now let us substitute the coefficient values in the Fourier expansion formula. it becomes like this. The a sub 0 is now this value, while a sub n is now changed into like this. We can simplify this complex fraction, so we have now pi squared over 3, then we copy this summation expression. This is now the final answer.